This video addresses the empirical rule and how the empirical rule is used with some data to make inferences about a population mean. The empirical rule states that for any distribution of data, most of the data values will fall within 2 standard deviations of the mean. And almost all, or virtually all, of the data values will fall within 3 standard deviations of the mean. Chebyshev's inequality actually quantifies this for any number of standard deviations. Chebyshev's inequality states that at least 1 minus 1 over k squared percent of the data values will fall within k standard deviations of the mean. It provides a bottom level. At least this amount will fall within k standard deviations of the mean. For 2 standard deviations, for instance, k would be 2. So 1 minus 1 over k squared equals 1 minus 1 over 2 squared, which equals 1 minus 1/4, which equals 3/4, or 75%. So the empirical rule, or Chebyshev's version of it, states that most of the data, or at least 75% of the data values, will fall within 2 standard deviations of the mean. For 3 standard deviations, k would be 3. So 1 minus 1 over k squared is equal to 1 minus 1 over 3 squared, which is 1 minus 1/9, or 8/9, which is 88.9%. So virtually all of the data, at least 88.9%, should fall within 3 standard deviations of the mean. It turns out, for many distributions, this percent is much higher. It's very rare to have data values fall farther than 3 standard deviations from the mean. Visually, the empirical rule can be seen as a series of intervals. The mean plus 2 standard deviations and the mean minus 2 standard deviations. At least 75% of the data will fall within 2 standard deviations of the mean. For 3 standard deviations, at least 88.9% will fall in the interval, the mean minus 3 standard deviations to the mean plus 3 standard deviations. Notice in this figure, this is true for symmetric or normal distributions. But the empirical rule states that it's also true for non-normal distributions. So here is a skewed distribution. Note the mean and then the interval. At least 88.9% of the data will fall within 3 standard deviations, or the mean minus 3 standard deviations to the mean plus 3 standard deviations of the mean. Again, it's very rare to find data values that fall outside of 3 standard deviations of the mean. They happen, they can occur, but it's just a rare occurrence. So, to use the empirical rule to make an inference, we're going to consider a problem. The university bookstore claims that all NKU students, or all students at NKU, spend an average of $400 per semester on books. So the bookstore is making a claim about the mean amount of money that all students spend on books. That's the population mean. Suppose it's known that the standard deviation of the amount spent on books is $100. If the claims of the bookstore are true, if the claims about the mean are by the bookstore are true, then the empirical rule states that virtually all students will spend between the mean minus 3 standard deviations, so 400 minus 3 times 100, which is 400 minus 300, or $100, and 400 plus 3 times 100, which is 400 plus 300, or $700. So, if the claims of the bookstore are true, then virtually all students should spend between $100 and $700. Now, we're going to use that data, or those facts, rather, to assess the claim. Okay, so if the claims of the bookstore are true, then virtually all students will spend between $100 and $700. To assess this claim, or any claim, we need to collect some data. That's what statistics is all about. Now, this isn't necessarily the best way to assess it, but any data provides an assessment. I'm going to collect one data value. So I'm going to ask one student, my daughter Hannah. Suppose Hannah spent $220 last semester on books at NKU. Since this value, $220, is within the expected range, is within the range that's expected if the claims of the bookstore are true, then there's no reason to doubt the claims of the bookstore. If, on the other hand, Hannah spent $820, well, $820 is outside the range which is expected by the empirical rule. This obviously can happen, but if the claims of the bookstore are true, then virtually all students should spend between $100 and $700. We found a student that spent $820. This does not state that the claims of the bookstore are untrue, but what it does is it raises some doubt about the claims. So, what we've done is we've collected data and we've made an inference about a population mean. If that data value falls within the range that's expected, then our inference is that the claims of the bookstore, the claims about the mean amount of money that students spend on books, is possibly true. If, on the other hand, that student's data value falls outside of the expected range, then our inference would be that we have some doubts about the claims of the bookstore about the average amount of money spent by all students on books.